So I'm Justin Meyer, and I'm going to talk a little bit about how to deploy your Python application securely. And there's a variety of different ways that can be approached, different aspects to talk about. The major ones that I'll focus on are sort of the server environment side of it and the web environment side of it. Obviously, not everyone who's working in Python is working on the web, but it is a fairly significant component. So those are kind of the two areas that I'll focus on, and let's dig right in. So first thing about me, I design and build web and mobile products. An unreasonable amount of time, and particularly in recent years, has been spent on security, and I'm in the process of rolling up some of the things that I've learned, and my team and I are building something called Monitorial, which you can check out if you are so inclined. So the first thing that I'll mention is that security is not a one-size-fits-all type of thing. So a lot of the things that I'll talk about, some of them will be applicable, some of them will not. I'm trying to focus on the low-hanging fruit, the things that, if you can, everyone should at least take a look at and see whether or not it makes sense for you. Obviously, in the end, you're responsible for the security of the things that you're working on, you're building. So work on what's best for you. And last but not least, if you work in software, you are a security professional. And whether that makes sense initially or not, one time I was talking, this is a while back, and I was talking to someone who has all of these certifications, and we were talking over lunch, and I had said something with the caveat of I am not a security professional, and he said, hold on, you work on software? Yes. Okay, and it matters to you whether or not your stuff is secure, or not secure, hacked, compromised? And I said, well, yeah. I said, well, you're a security professional. So that's something to keep in mind if you work in software of any kind. So one of the overriding themes of this talk is up on this slide. Security is hard, it is boring, it's important, and it's always changing. The one thing that I'll say is it doesn't have to be boring. I say it's boring not because that's what I think, but because that's kind of a common feeling that people have about it. Most people, understandably, when you're trying to build a product, you're interested in building your product. The security is sort of like writing unit tests. It's one of these things that it just gets in your way as you're getting to your eventual end goal. No one wants to spend time, hardening things, and I sort of find the fun in it. To me, it becomes kind of like some silly cat and mouse game where I feel like I'm trying to stay one step ahead of the ne'er-do-wells. But the most important part is that it's always changing. Just when you think you've got it all dialed in and you have everything set, something will just come out of the blue and give you maybe not such a great day that day. And so always trying to stay on top of things that are changing is an important part. So, this has kind of come to, it's gotten much more attention, over the years. And a lot of them haven't been particularly fun for those of us who are in the business of trying to make sure that these things don't interrupt services. It's like I add these things every once in a while, and you can probably name some of these just by their logos. I think it's hilarious that something is as severe as a potentially career-ending software vulnerability is given these cute little mascots as poodle, ghost, drown. I mean, at some point I just gave up, and I'm like, I'm not adding any more new ones to this. It's, you have these people that come up with these, attacks that I don't know if they have their own marketing departments or how they, how they come up with these things. But so, why is this happening? Why, do these incidents occur? And when I talk to people at Thanksgiving or some holiday event and their family, and I think that this is what they imagine that we do, right? Like that it kind of looks and feels like this. When the reality is, it's a lot more like this, right? It's a Rube Goldberg machine. It's a series of decades of crusty layers of code on top of one another. Not to say that there aren't smart people that are doing great work, because of course there are. It's just the reality. If you looked at chaos theory or any complex system, and this is, I think, the most complex system ever devised by human beings, you're going to have problems, and there's going to be ways to compromise these systems. And so the implications for that is that there is a very high degree of systemic risk for desktops, for servers, and increasingly for the Internet of Things. If you ever have the pleasure of listening to Cory Doctorow give a talk on digital rights, or as some of them call it, digital restrictions management, and some of the implications that that has for, not just like light bulbs and, thermostats, but for, thermometers, for, our bodies and, implants. Anyway, it has a lot of implications that aren't always immediately obvious. So the first line of defense for this is unattended upgrades. And the thing about unattended upgrades is that they're not always unattended. And what I mean by that, and I'll have to sort of back up for a moment, I think that there's an increasing generation of folks that have never had the pleasure of ordering a physical server and had it arrive, and then in a separate box you have your CPU and then you have your drives, and you sort of assemble all that together, and eventually you rack it in along with the rest. Nowadays I figure like most people are much more familiar with spawning an instance, VPS in a matter of 10 seconds. But if you do remember what it's like to work with physical servers, you used to get you used to have a plastic spinning disk that you would put inside it, and you would have this guided OS installation. And one of the options in that menu is unattended upgrades. Do you want them? Well, the thing is, in this transition from physical servers to virtual private servers, that sort of guided wizard approach isn't really followed anymore. And there are good reasons for that, as we'll get into, but the point is that instead what they provide is an optimized one-step, bam, here's your OS, install, here's your prompt. The whole wizard business has been kind of dispensed with. And again, there are good reasons for that. There's no, it's safer to, it's easier to not have to go through that whole process and just get your prompt. And the other thing is that so then the question is, okay, well, if you have to choose defaults, do you choose to ship your OS image with unattended upgrades on or off? Well, it's theoretically safer, from a principle of least astonishment perspective, to not have them turned on, right? Because if you have it turned on and someone wasn't expecting it, and for some, 1 in a million reason, some OS upgrade knocks off your application, and you didn't tell it to do software upgrades by default, you might be unhappy. And so they do the safer thing for them by having that not turned on. And so what that means is, from the moment you deploy your virtual private server, your system is vulnerable. So how do you fix that? So you say, okay, well, if you're on Debian or Ubuntu, or if you're on Red Hat, here's two different methods of installing unattended upgrades. It's called something different in the Red Hat world. I just use the Debian Ubuntu term because that's what I'm more familiar with. And so you install unattended upgrades, and all is well. Or is it? You would assume that it is. But the thing is, you've installed it, but it's not enabled. So you think that you're covered. You've installed it, you're all good to go, but the reality is that nothing really has changed, and you're just as vulnerable as you were before. Well, how do you fix that? Well, by mucking around as root in a text file. The same way you do anything meaningful on a computer, for reasons that are still not entirely clear to me. So you make a couple modifications to some arcane path on your system, and at that point, thankfully, you are now covered from a automatic upgrades perspective. It's a little bit more involved on Red Hat. You have to do 2 extra things beyond modifying a text file, but it's essentially the same basic process. So that's all fine and good. You're now getting, depending on the setup, every 24 hours, you're getting some kind of unattended upgrade. What about reboots? If it's a kernel level fix, and at that point you have to reboot the system in order for that to actually take effect. Otherwise, you're just right back where you started in terms of being vulnerable. And so, how do you know? And most people don't even know their systems have to be rebooted unless they log in and they see the little message of the day thing, if that's indeed provided by your OS vendor, that you need to reboot your system. Well, what if it's been 3 months? Since the last time you logged into it. If your thing's up and running and you don't need to log in, well, you wouldn't know, and it would be just vulnerable for that entire time. There's a couple of solutions. One is email notifications, which, again, manual mucking around in a text file in order to enable that. And there's automatic reboots. And of the two, I think I would probably go with the email notifications. The last thing you really want is your machine just rebooting spontaneously when you weren't expecting it. You might be on holiday and find out that something didn't quite come up as cleanly as you as expected, and your service is offline. So that may not be a good idea. Another potential option at some point down the road is live kernel patching. That came out, sometime in the last year. It's available to varying levels of support depending on your distro. But it is an involved process. This means that you, in theory, wouldn't have to reboot. They would just live patch your kernel. It's generally not user-friendly or enabled by default, and unless you really know what you're doing, unless you have really good reason to do it, I'm not sure it's worth the effort. So if you do manage a server or ever log into one, generally speaking, you're doing that via Secure Shell or SSH. One of the comments that I found on the internet one time about this said, this stuff is complicated and badly documented and doesn't really work great. And to me, it was a pretty good summary of SSH configuration. And again, I don't mean to be, sort of a negative Nancy the whole time. This stuff is just messy sometimes, and so if it seems negative, my apologies. Here's a big wall of code that I'm not going to go through line by line. And by the way, no need to take notes or anything like that. This will be available on my site at justinmeyer.com within sometime this afternoon. And so, this is just the configuration that I use. There's some important things in here in terms of making sure that password authentication is off. Once you have a public key connection to your machine, there's really not a whole lot of reason to have password authentication on. You'll just, sometimes for fun, I will spin up a Linode instance and wait an hour, just for fun, and then I'll log back in, and it'll say, there have been 6,842 unsuccessful connection attempts since your last visit in an hour. So, there's these automated botnets that are constantly hammering, just random IP addresses, including yours, all the time, and it's, the chance of them, if you choose a good password, the chance of them brute forcing your machine is unlikely, but don't even take the chance and disable password authentication. I choose a particular mix of host key algorithms, key exchange algorithms, ciphers, and message address codes that are meant to maximize forward secrecy as well as just general overall integrity of the connection. I do the same basic thing at the client level, and you can have fallbacks. So you can say well, Bitbucket and GitHub, they don't support the ED 25519 elliptic curve, and so I'm going to fall back to RSA for stuff like that. And so you can have some granularity in terms of providing the best possible protection for whatever it is that you're connecting to. And I'm also doing the same thing on the SSH-D or the daemon configuration as well. So in summary, SSH configuration is a bit of a mess, and there's some good resources for this that I found really useful, and I suggest that you check them out. And the other thing to remember about this is that the cryptography changes constantly. Not necessarily on a daily basis, but it's something you want to keep an eye on. So for example, recently I was taking an inventory of some of the systems that I log into, and I noticed that a good number of them had 1024-bit DSA keys on them, and the industry has essentially deprecated those as not being secure, and so it's just those things can persist for much longer than they should. So just try to keep an eye on that and schedulely perform reviews and try to rotate your keys. One thing I'm just going to go through really quickly is the notion of automatic bans on repeated authentication failures. I use a tool called fail2ban. It looks at log files for malicious signs of behavior. It will automatically update your firewall settings to reject the IP addresses of bad actors. You can also take any other arbitrary action that you want. You can have it notify you, anything that you want it to do, it can do. So this is just an example configuration that I've used to monitor the log files for SSH. When I see someone who's who's attempting to hammer a server, even though password authentication is off on all of mine. But when you see someone trying to hammer at your server, I just don't need that stuff cluttering up my logs, and even if it's only a small amount of CPU time for them to do that, it's just annoying, and I just prefer that they go away. So this helps them go away. And this is not just for SSH. You can use this to monitor Apache logs, Nginx, FTP. Please don't use FTP. But you can use it for for anything, for any log file that you want to monitor. So rootkit detection is a tool that looks for rootkits, backdoors, other exploits. It also just sort of looks for files that it thinks like maybe shouldn't be there. Hidden files in etc, for example. It will say like maybe this thing got placed there, then you didn't mean for it to be there. And so it compares the hashes of known good files with other files that may appear after that fact. And you can tell RK-Hunter, like for example on Debian or Ubuntu, you can tell it like, hey, this is how, please monitor new packages and make sure that you are keeping an eye on those, hashing those things and comparing it against any new things that might arrive. And sometimes I'll find that there's legitimate things, like say a mercurial directory or other things that will end up in directories that it monitors. And this is a way of telling it like, hey, yeah, I know those things are there. I put them there. You don't need to warn me about them. So that's sort of the server side of things. If you're deploying a Python application, if you're not using if you're using something like Heroku or wherever where they've abstracted all the things that I just talked about away from you, then you don't need to worry about them. But a lot of times people are using VPSs or other things, and that's where everything I just mentioned comes into play. Now we'll talk a little bit about web security. Then so the web security is not just about the web. Like I'll talk to folks and they'll say, I don't really need to worry about the web. I'm more of a back-end developer. And I'll ask, well, do you build REST APIs? And I say, sure, yeah, that's a lot of what I do. I'm like, okay, well, then you need to deal with web security because that's essentially what you're doing. You're just dealing with the back-end side of it instead of the client side of it. So for fun, I went through and looked at, I was trying to figure out like a good way of evaluating how common some of these things are, and some of the things I'm about to talk about, that is. And so I went and I said, well, what better place to look than my own banks, my own health insurance company, and this popular e-commerce site? Well, why did I pick those? Well, I thought, what is the most valuable data that I have? I mean, it's my financial transactions, it's my health data, and it's all the stuff I buy, like throughout the unholy amount of time that I've been an Amazon member. And so I went through and checked all of these sites for some of the things that I'm about to mention, and they didn't fare too well. And I think that if I really were to have one overarching point of this talk, it would be we can do better than this. Like these are Fortune 100 companies. These are huge companies that have entire departments, and some of these things could be addressed by a one-line config change in a web server, configuration file. Is that going to make like a night and day difference in terms of the security that they provide? Who knows? Maybe, maybe not. Probably not. But it's a one-line thing that strengthens it ever so slightly or not slightly. To some degree, it's making it stronger, and yet people aren't doing it. So, if you work on anything related to what I'm talking about today, just try to remember that it's not just your data. It's your family members' data. It's your friends, the people that you care about. Maybe not directly. Maybe not there. They may not be using the stuff that you're building, but other people are building the stuff that your friends and family members are using. And so, just try to do your part in making the world a better place by trying to get some of these things as well done as you can. So anyone who wants to have a bad day can go and provision and deploy a TLS certificate. Some folks may say like, "Oh, it's not that bad." You log in, it's bad. Okay, like you go in there, you put in your credit card, it says, okay, put in your CSR. All right, so you gotta go log into your machine, get your CSR, copy, paste that, put that in there. Then it asks you for a whole bunch of other verifying information. And then it will, theoretically, when you're all done with this, send you some undetermined point later, an email attachment containing your certificate. Well, first you have to approve the confirmation message, and then you get emailed your certificate, and then you have to copy and paste that into the whole thing is a mess. It's at least, it's tedious at best. So the good news is there is something that fixes this, and that's why I love Let's Encrypt, and we'll talk about them all day long. At this point, it's no longer a new thing. I'm sure most folks in here are familiar with it, but if you aren't, it's an automated TLS certificate generation and provisioning tool, and there are various ways of authenticating when you use it. You can authenticate via a built-in Apache or Nginx plugin. You can use a file in your web root that it looks for. You can do it manually. There's a standalone method where you can essentially, where you have to temporarily bring down your web server. It will then spawn its own, authenticate. It will then quit, and then you can bring yours back up. Obviously, there's some downtime associated with that, however minimal, but for some folks, that is extremely annoying and a deal breaker. The newest one is DNS-based authentication. I was super excited about that until I realized some of the downsides to it. So I won't go into what those are just because for time reasons, but I was excited, but it doesn't suit our needs for the moment. We use a combination of either web root or standalone. Installing Let's Encrypt is very easy. You can pip install it. It's called. This is actually somewhat outdated. You can replace the words in here Let's Encrypt with certbot as the new name for it. I need to obviously update this slide. But certbot is almost entirely written in Python, and it's a well-written client. There's a variety of others, but it's really well done and has a lot of automatic stuff built into it. As far as provisioning, you can use configuration files. You can also pass a lot of those arguments directly on the command line. This is just an example that will provision a certificate for monitorial.com. And the web server configuration is correspondingly straightforward. You just specify one location, and this location doesn't change. Even though your certificates are going to be renewed every 3 months, this location will not change. It's always constant, so you don't have to change your configuration every time you provision a new certificate. And the nice thing about open source is that there's a whole bunch of other clients out there. You don't have to use certbot. There's tons that do all kinds of other interesting things, and you should check them out if certbot doesn't do what you want it to do. So one of the things that I mentioned in that sort of analysis of the sites that I use for finances and healthcare is this is one of those line items, and that's called strict transport security, and it's essentially a signal to the browser from your web server saying like, hey, we only deal with HTTPS here, and you can read a little bit more about it on OWASP's site. The configuration is, as I said before, really easy. It's one line. This is not a difficult thing to implement. It does not depend from one site to another. So you don't really have to make any, other than changing what you want the maximum age to be, if that's something you want to change. There's no other changes that are required in terms of from one site to the next. Here are a few other additional headers that you can add, and each of these adds a little bit of protection to what you're doing. Mostly in terms of mitigating cross-site scripting attacks. There are some other easy wins that you can see here. Some of them have to do with which SSL protocols that you enable or do not enable. And everyone has to kind of figure out where you are on the spectrum. Some people think to themselves, okay, well, I only want to deal with modern clients. Other people say, I want to support super old versions of Android web browsers that run in various parts of the world, and depending on where you fall on that, you have to choose your SSL protocols and your server ciphers and all of those things appropriately. Mozilla has a great page where they describe some of the I think they have 3 levels. Sort of super strict, intermediate, and permissive, meaning we want to support the widest range of clients. So I'll talk a little bit about OCSP stapling briefly, once again, for time reasons. But It was originally called the TLS certificate status request. It's essentially appends or staples these time-stamped certificate authority signed responses to the initial handshake. It's fairly easy to configure. Again, not something that really changes from one instance to another. So it's essentially a copy-paste sort of type of thing. You can choose, how long you want the resolver timeout to be. But other than that, it's pretty straightforward. It provides, some additional security. Content security policy is tougher. These are not sort of like copy-paste kind of things that you can do, because these are, from here on out, a lot of this is very specific to what you're doing. So you can, it's essentially a whitelist, and it works for JavaScript, CSS, images, fonts, and really anything else that's delivered, to your browser. You whitelist what is allowed, and everything else is blocked. And one of the other things about it is that it explicitly disallows inline scripts or CSS. And anyone who's working with a legacy, code base, you may find a lot of inline scripts or CSS. And even when you're not dealing with legacy scripts or legacy code, there's frameworks that will dynamically inject this inline into your code. And this is where CSP gets to be tricky. One of my colleagues said, I think for a site of any complexity at all, you need to build for CSP from the very beginning. Because it's a pain when you're taking an existing site and you're trying to make it work. It's just tricky. Whereas if you do it from the beginning, then it kind of, in some ways, works as like a security compiler, right? You write your code, you write your CSP, you load in the browser. Well, if something isn't loading right, well, you've messed up the CSP, and you need to go back to and fix that. So it's great if you're starting from the beginning. It can be daunting if you're not. The configuration of it is, theoretically straightforward in terms of identifying the things that you are using and saying, okay, well, we bring some stuff in via Cloudflare or other CDNs. We use these images, and this can be locally or external. In either case, you want to whitelist it. But the thing is that these inline scripts and CSS are much more common than you may think. We found it in, even when we thought we got it all, we would find that we missed something on some obscure portion of the app or site. Constantly going and tracking these down and moving what's like a one-line inline directive into a separate file at some point starts to feel really silly. Like, really, it's just one line. Why do I have to move? This one line has to live in its own file? Well, yes, in CSP world, it does. And if you're using certain things like Adobe Typekit, well, it dynamically injects a bunch of stuff, into your HTML pages, and it means that CSP gets to be really hard there, and you essentially have to use the unsafe inline directive. And unsafe inline is sort of like a throw up your hands, I give up. Just we don't care that it's that we're making this insecure. At some point, unsafe inline is a way of just not really implementing CSP. It's like you're saying you're doing it, but you're leaving this big back door open. And it's unfortunately a blunt instrument. It's all or nothing at this point. You can't say like, okay, for a typekit, we want to use unsafe inline, but everything else, please do it properly. That's not really an option today, and I'm hoping that with, I've looked through the specs for CSP level 2 and level 3, and they're like this long W3C. It's hard to tell what it does and what it doesn't do, but I'm hoping that it allows that at some point in the future. I'll cover public key pinning very quickly. It prevents against certificate authority breaches like the DigiNotar infamous breach from a long time ago, and someone could impersonate your secure site, and this helps to mitigate that problem. Root keys can generate certificates for any domain, and again, this is meant to try to prevent someone from generating a certificate for your domain that appears to be valid, but actually is not. So when I first looked at public key pinning, I thought CSP was hard, and this seems like an order of magnitude more difficult. The reality is that it's easier than it seems, but you have to securely store and back up your keys and your certificate signing requests. And the consequences, if you don't do that, or if you do it and you lose those backups, can be very significant. this is just a process that shows you, like, this is how you generate your keys. This is how you generate your fingerprints. The web server configuration is pretty easy. You simply are pointing to the SHA-256 hashes of the files that you've generated. And the other thing is that public key pinning is really hard when you're using Let's Encrypt. Let's Encrypt regenerates the key pair each time, for every 3 months or whatever that interval is. It does that each time. And the last thing that I'll mention is that the consequences are much more significant. If you misconfigure this, there are, for example, just 2 weeks ago, Smashing Magazine, which is a popular design site, misconfigured their HPKP, and the result was that their site was offline for 4 days. It's 4 days where no one can access their site because they messed this up. And that's not a dig on them. It's complicated. So many people are essentially, in their minds, there are a lot of security folks that feel like we should deprecate public key pinning and instead focus on certificate transparency. And what certificate transparency does is this is a similar way of defending against forged certificates. The certificates are submitted to logs. The idea is that the logs then hand back what's called a signed certificate timestamp or an SCT, and that's basically a promise from the log saying, like, okay, we've acknowledged your submission, and whatever the determined interval is, we'll make sure that it gets added to the log. And this is becoming timely because as of last week, the team that works on Chrome and Chromium have announced that by October of next year that this is required. So if you have a site that runs on TLS and you don't have certificate transparency, your site just doesn't load in Chrome or Chromium by that time next year. Maybe they'll extend it, maybe they won't. That's always a sort of a cat and mouse game. It's coming up there, and as far as how that works today, it's a little new, and so there's going to be a lot of, I think, some speedy catch up over the next few months. It's 3 different methods. I'm not going to go into them, but the one that is probably the most realistic is the last one. I think that's the one that Let's Encrypt is targeting. They don't do it today, but the idea is that, say, sometime in the next 6 months, hopefully, this SCT will be bundled into the certificate when they deliver it to you. So in theory, you don't have to do anything, and you'll just get certificate transparency out of the box. How many folks here use configuration management of some kind? Okay, that's good. That's great. It's a healthier number than I would have expected, and that's wonderful. Both Ansible and SaltStack are great Python-based solutions for configuration management. I highly recommend it. All of the things that I showed you, these are all things that we use Ansible for this, and we have very detailed configurations that make sure that all of those things happen on every system that we interact with. So in conclusion, security is it's hard. It can be boring sometimes, and it is very important, and it's always changing. Try to do your best if you can to pay attention to it, to make sure that the stuff that you're doing is secure, and that thanks a lot for listening. And we have a few minutes for questions, so I'd love to hear them. So the question is certificate transparency essentially a substitute or equally viable solution as public key pinning? And my understanding is that it is in many ways. The idea is that you have this transparent public repository of certificates. So if a certificate is issued and it turns out that it's actually wasn't supposed to be issued, it's either forged or faked or somehow fraudulently issued, there's an easy way and an automatable way of checking for that by comparing the certificate that's being proffered to the one that's in the certificate transparency logs. So my understanding is that yes, it should be a good proxy for public key pinning.
I'll fill the last minute. So the deployment by configuration is very nice when you spawn machines from scratch. What when you run something like Kubernetes or Dockers or stuff like that? Would you embed that security in the lower layers, or how would you proceed?
Yeah, so containers bring a whole nother level of I can give an entire other talk on how to manage container security in a environment such as Docker or Kubernetes, and those are you can use some of the things that I mentioned. Obviously on the web security side of things, all of those things still apply. It doesn't matter whether you're serving it via Docker or directly from bare metal. But some of the other things, from the operating system level, again, are sort of abstracted away for you. But the containers themselves are essentially, OS images, and there are some of them, depending on the container you're running. The ones that are done well, in theory, are running a single process, generally the one thing you want it to run. But there are other times where containers have all kinds of things baked into them. They'll have an SSHD server in it. It'll have supervisor running to try to keep processes up and running. And you've now created a virtual machine, sort of in a container wrapper. And I'm not, there are some people that look at containers as lightweight virtual machines, and other people would say, well, that's not really what containers are for, and you're doing it wrong. And I don't take a position on either side. But if you are using it as lightweight virtualization, then all of those other items that I mentioned would likely come into play as well, because you're essentially just doing the same thing as you would be otherwise in terms of having these things that you need to monitor. And if you have SSHD running on your container, then you have to make sure that someone can't easily get into it. So yeah.